Today we will understand the IPSEC, how much you need to know for the interview purpose. Let's start from the basic. Suppose we have a headquarter and we have a server placed in the headquarter, and we have one firewall placed in the headquarter. This is how they are connected. And the another side, we have a branch office, and they are also connected to the all the system in the branch are connected to the firewall. Of course they are connected via the switch, but I'm just showing you the high level. And then this is the subnet for headquarter, and this is the subnet for the branch. Of course there is the internet from where we can connect these both. There is another method like lease line, MPLS, but those options are very costly, and yeah, you need to pay more. However, internet is not that much costly. It's very cheap, and with less amount of money you can get more speed. So we will choose the internet as an option. So what we need to do to connect over internet, we know internet is not secure, so we need to configure some kind of tunnel to connect these two offices. So we will use here IPSEC tunnel. Okay, to connect both the offices with each other, we need to have some kind of IP address in our external interface. Here I have just added the private IP address, but in your scenario it will definitely be some public IP address. So let's take these two IP address in our scenario. So this is how the connectivity will look like. So now you understand why we use the IPSEC VPN to connect two different offices together, and why we want to connect them together. Let's take an example. In headquarter, there are so many servers which has to be accessed by the other employees, but those employees are not working in the headquarter, but they're working in other locations. You just take an example. Your headquarter suppose is in London, and you have another branch which is in India, Mumbai. So Mumbai want to access the applications, how they will access. Okay, so they cannot go to headquarter, but of course they want to access when they're in Mumbai. That's why we create the VPN. Okay, so that's the purpose of creating the IPSEC VPN. Let's go to the next. IPSEC Vpn Basics. How many things you need to know as part of the IPSEC VPN? It has two phases, phase 1 and phase 2. Phase 1 is used for the device negotiation. It exchanges couple of messages. Device negotiation is like, if we go back to our previous diagram, we know that if VPN has to establish, it has to establish between this and this firewall. Of course, once the VPN is established, the data will start transferring. Okay, suppose here there is a payroll website in our headquarters, and these guys want to access this website over the VPN, right? So after establishing VPN, this traffic will go. But before that, these devices need to negotiate. They need to create a VPN, and that's the phase 1. In phase 1, device negotiation happens. They exchange a couple of messages. So now you might be thinking how many messages they negotiate, and what are the different ways to exchange those messages. So there are generally two modes in phase 1. One is main mode, which has 6 messages, and another mode is aggressive mode, which has 3 messages. Keep in mind that these messages are exchanged between those firewalls, two firewalls. As it is mentioned, the negotiation happens between the devices, device negotiation. Okay, so these two will negotiate the message, they will agree on them, and then phase 1 will become up. Okay, so we know now phase 1, and there is a phase 2, and the purpose of phase 2 is the transfer the data. Okay, for transferring the data, the good thing is there is a phase 2, and there also a couple of messages has to be exchanged so that phase 2 tunnel will become up. So you can also consider phase 2 like a tunnel inside tunnel. Phase 2 goes inside of phase 1, so it's more secure, right? So now again the same question, how many messages are being exchanged? So there are 3 messages being exchanged, and in phase 2 we only have one mode, that is quick mode. Okay, so this is the high level of IPSEC VPN. Again, the same thing. Once the negotiation happens, phase 1 is up, phase 2 is up, then the data transfer will take place. Okay, so these guys will start accessing the application. Okay, again continuing on the IPSEC basics, there are other things that you need to know. Why we use IPSEC, like to connect two devices, to connect two offices together so they can access the things like branch office can access the application placed in the headquarters. Like for the sake of the security, there are three things that you need to keep in your mind. With IPSEC, we achieve confidentiality, integrity, and authentication. If you see, the confidentiality means your data is confidential. Nobody else can see your data. And how it happens? It happens with the help of encryption. And there are different methods for encryption, 3-. They are really weak, but you will still see the options, couple of devices. However, there are strong methods which are AES 128 and 256. You can use 128, that is also secure. 256 is way more secure. But please keep in mind that if you will use higher algorithm, like instead of AES 128, you will use AES 256. Your firewall need to do more processing to encrypt and decrypt the data. It could spike your CPU and RAM. If you have a good firewall with very good configuration, like high CPU, high RAM, big model, you don't really need to worry about that. You can just go ahead and use 256. The next is integrity. Integrity is like hash, you can say hashing. We use integrity that for the reason that your data is going from one place to another place. It should not get changed. Like you sent somebody $100, they should not get changed to $10, right? This is just an example. With the help of hashing, we achieve that integrity that is not changed. There are different algorithms for that, MD5 and SHA. MD5 is a weak, and there are many versions of MD5, but all of them are considered weak. So better use SHA. SHA, again, SHA-256 is the strongest. You can use that. Okay. And the third thing is authentication. For authentication, we have two choices again, pre-shared key and certificate. Most of the cases you will see everybody is using pre-shared key. Okay, but the best and the secure method is to use the certificates. Okay, so there is another thing that you need to know, header. That's a short form created by somebody, not by me. And this is really nice short form to remember the couple of messages being exchanged. If you remember, I have told you that in phase 1, there is a main mode and aggressive mode. In main mode, 6 messages gets exchanged. Now this is a time to think what goes inside those messages. Okay, so header is the information which goes through those messages. H is hash, A is authentication, D is Diffie-Hellman, and I think here I have mentioned it incompletely. H is hash, and in hash, again, we just discussed SHA-256. Let's take an example. We are using SHA-256. And then authentication, you have two options, pre-shared key and certificate. Diffie-Hellman is a key exchange method. This is a different topic. You can go ahead and check, do search on that. But Diffie-Hellman, with the help of Diffie-Hellman, we create a shared secret key. Okay, so another one is L, that's a lifetime. Just take an example that your key will not be expired for 8 hours. Okay, that's why we use lifetime. Then we use encryption. For encryption, you can use AES 128 or 256. Okay, now let's see what are the messages goes inside. So there are, of course, 6 messages, but the good thing is, like, you don't need to remember all the 6. First message and second message are same. The only difference is the first message is being sent by initiator and the second message is just responded by the responder. So we have two things here to notice: initiator, who will initiate the communication; responder, who will respond to the communication. Okay, so as I explained to you in the previous slide, header information will go, right? So initiator will send the header information and responder will send its own header information, and then they will say all okay, and let's go to the let's go and send the third packet, which is I will discuss in a couple of seconds. Before going to the third packet, let's see what goes inside that. We just discussed header. This is the information that they share with each other. They just another thing to notice, they of course say, okay, let's use SHA-256 for authentication. I'm not going to use digital certificate. I will use pre-shared key. Also, another thing to notice for an exam, for question perspective or exam perspective, if somebody is asking you like your password goes inside a first message, no, password doesn't go in a first message. First message is all about the methods that we are going to use. Okay, so we are going to use the SHA-256 as a hash, but hash doesn't go in first message. Only the method goes in that, algorithm goes in that. And Diffie Hellman, there are different groups for Diffie Hellman. So suppose we are using 19, suppose lifetime we said, okay, 8 hours, and encryption we are using 256. And the another guy will also reply with that. Notice here another thing. So all other things I have kept same, but encryption you can see I just mentioned AES 128 and 256. The responder or the another party can have more than one encryption or hashing, okay? But he should have at least the one with matching with another party, okay? Why that's so? It's exactly same as suppose you are going to talk with a person and you know English, the another guy knows Chinese, but if he also knows English, then you both can talk with each other. But if he doesn't know English, but he know Chinese, he know Spanish, so many other languages, but he doesn't know English, so you cannot talk to him even though he has so many knowledge of different languages. Okay, that's why at least one should match. You can have more than one. Okay, so now it's the time to go a little bit interesting picture. So the first message, it is of course from the initiator, which we have seen here. Initiator, he will send the message. If you remember, we have this IP address 0.1 and 0.2. 0.1 is our initiator, which is source, and 0.2 is our responder that will become the destination. Okay, the source port is 500, so 500 port is being used for IPSEC VPN. We will discuss this later. And then you have here initiator and responder. Okay, so there is an initiator value that's called SPI, initiator value, and responder SPI. Responder SPI is always 0. This is how you identify the message. Second message will be exactly same, but how you will identify if it is first message or second message, this is from here you will identify responder SPI. Okay, and then which version we are using? We have ISA-KMP, Internet Security Association Key Management Protocol. There's something else you need to remember. This is used to share, this is complete protocol used for key management. Okay, so we have 1.0 version that we are using. Inside that we can use IKE version 1 and IKE version 2, but I have not explained you that, so you can just avoid that. And then you can see this is proposal number 1. This is here the interesting part comes. I've told you that in first message header information goes. So header can be up and down, okay, so that's just for you to remember. So in header there was E, that's encryption, so you can see AES CBC. The key length is 256 for encryption. Hash algorithm, they are using SHA-2 that's really strong. Group description is this one, 2048. By the way, I have taken this from the internet, this screenshot, to explain you. I think it's interesting for you to understand how it looks like in a Wireshark. So authentication method, we are using pre-shared key, and lifetime seconds. How many duration is like the same that we have said, lifetime 8 hours. It is using 8, 6, 400. Okay, so the second message looks exactly same. See, everything is same. It should match with the first message, of course. So everything is same. You can pause the video and you can compare. But the interesting thing here is you have responder SPI. Okay, how you will know then about the first message and second message? First message will always be having 00 responder, second message will be having responder, but all other messages will also be having same initiator and responder key. So the second thing to identify second message is you need to look into this information. They are called transform. So we set header as a short form. They are called a transform. This is the information they're going to send each other. Okay, now third and fourth message. Again, so this is a negotiation of Diffie-Hellman. Okay, Diffie-Hellman, there is a group where we said like we are using 19 group. They negotiate with each other. They could send a couple of messages. That's there is a mathematical formula behind that, and if you know about that, then you know how it works. With this help, with the help of Diffie-Hellman, we negotiate shared secret key. Okay, and if everything is okay, most of the time for the troubleshooting also, you will never see any issue in message 3 and 4. If you will get a second message, you will always get third and fourth message, and the problem will come in the fifth message. That's good from interview point of view and also troubleshooting point of view. How our third message looks like. This is what I told you. If you remember, except message 1, all other messages will be having same initiator and responder SPI. Okay, so from here you can only identify first message if it is 00. You cannot identify remaining messages by looking just the packet. I can identify by just looking into output any message if it is third or fourth. You can also do that. And how is that? The thing that you need to notice in the third message, the nonce value goes. Okay, this is nonce data. This is like a random value they exchange. Okay, if you will know the Diffie-Hellman algorithm, you will come to know why they are using this random value. Okay, another thing is if it is third or fourth, because that again looks exactly same, you will see exactly same it looks like. Okay, maybe the nonce is different. You can see nonce is different, but that will not make you any hint if it is third or fourth message. How you will come to know about third and fourth is from here, source address and destination address. If it is a, let me go back. If it is 0.1, we know this is our source and this is our destination. If it is reply is coming, we know it's a fourth message. Now let's go to fifth and sixth message. So in fifth and sixth message, identity, that is peer ID. When you will configure the VPN, there is option as a peer ID. If you do not configure peer ID, then IP address will go in that as a peer identity. Then there is a pre-shared key. In the first message, if you remember, we have used method for authentication as pre-shared key instead of digital certificate. But the value will not go in a first message. Value will go in the fifth message. What else will go in this? Hash payload. If you remember, we used the hashing algorithm. I think SHA-256 we mentioned. The value, the hash payload will go in this fifth message, and the same thing from the sixth message. Okay, and another important thing to notice, if all okay, then they're done, phase 1 is up. Another important thing to notice here is these two, fifth and sixth, are encrypted. Okay, so you cannot see what's going inside. That's the beauty of using main mode, and that's also exam question. They can ask like which message in IPSEC VPN is encrypted. So now from here you know that fifth and sixth are encrypted. This is how it looks like. They are encrypted because your pre-shared key is going, right? So you cannot send your pre-shared key, means your password, over unencrypted channel, right? So that's why they are encrypted. Now here you can see how they look like. Again, 0.1 is our source and this is our destination, port number 500. This is from where you can identify, this identification. Okay, and you will see like fifth and sixth, they have the same identification. The previous one also has an identification. The only difference is 0.2, right? This is destination is replying, and if I go back, this is source is sending the message. Okay, this is all you need to know as part of phase 1 and high level of IPSEC. There's another thing that I want you to really notice. That's the short form I mentioned, EIISA. Okay, so what are these? So this is a little bit additional information you really need to know. ESP, encapsulating security payload. This is used for confidentiality and authentication purpose. Okay, That's it you want to know. When phase 1 and phase 2 is up, then your data has to go from one place to another place. At that time, you will see in the Wireshark, all the packets are ESP packet, encapsulating security payload. After that, you have AH, that's authentication header. This is used for integrity and authentication purpose. Interesting thing to notice here is in this, we do not have any encryption. Like confidentiality, if you remember, that's for encryption, right? We do not get in the AH that. What you can do, there's another way to use these both in the combination like ESP plus AH. Okay, because if you go into detail in AH, there are some benefits of AH, so you can use that. If you talk about the FortiGate firewall, you don't need to do anything by default. They are using ESP, they are not using AH as per my knowledge. Maybe they are using, but as far as I studied, they are using only ESP. Then there is a security association, the header information that we have shared with each other, then they agreed, so that's called a security association. IPSEC-IKE, you have seen in Wireshark, there was IPSEC-IKE protocol that is used for like Internet Security Association key management protocol. Like this is for managing the key. You negotiate couple of the packets, all those packets are going from here and there with the help of IPSEC-IKE protocol. Okay, so SA is the same here, security association. They do over the internet for managing the key. This is how you can remember that. Internet key exchange. So you have seen like we were using version 1 in that. If you don't remember, let me go back, because here is like IKE, Internet Key Exchange, and there are two versions, version 1 and version 2. Version, like mostly I see still version 1 is being used widely, but version 2 is more secure. It's much better. There are a lot of benefits of version 2. Okay, so I would just say you just use version 2. You can see here there was somewhere version 1 is being used. So this is the IKE version. I hope you liked the video. Please share it with your friends. This video will be very helpful for you if you're going for any interview. These are the only things you need to know from interview perspective. And also if you're working in a company, you only need to know these things. There is a hell amount of information on IPSEC VPN. You don't really need to know into more detail. The next video will be on a phase 2. Okay, so I will show you the packets of phase 2, and there are some additional information that I will give you that you need to know part of IPSEC VPN. Okay, bye.